Hello, my name is František Siegel and I would like to show you today one of the tools which we use in IDIADA and which is extremely useful when debugging Abacus implicit simulations. Implicit simulations in general have problems with their numerical convergence, either because of the model complexity, nonlinear behavior, contacts, or any other aspects of the implicit type of simulation. And since each simulation can suffer from its own specific issues, model debugging process can be extremely time-consuming and exhausting even for an experienced CAE engineer. That's why we created a tool called Message Analyzer, which is supposed to help us to identify, understand, and fix the reason of either bad or no convergence of the simulation. The ordinary way of debugging process of a simulation with convergence issues requires manual checking of message, DAT and STA files. These files contain a lot of information, but just some of them may be related to the main issue, and that's why Message Analyzer is so useful. Message Analyzer processes and analyzes these files, extracts all the relevant pieces of information and provides them to the user in a graphical user interface where we can easily check all the reported model entities, use filtering, sorting, or to check the number of occurrences of these entities in the report, etc. Another great feature is heuristic analysis of the simulation. Based on the know-how of our most experienced CAE engineers, we introduced and implemented the symptom issue measure relation mechanism. Heuristic analysis automatically searches in all collected pieces of information for symptoms and links them directly to particular issues and provides a corresponding proposal of measures which will be applied in order to fix or to prevent the issue from occurring in the simulation. Heuristic analysis is able to identify and point directly to the entities responsible for the issue, as if one of these experienced CAE engineers sat right next to you, providing you with the most valuable hints and recommendations. Graphical user interface is designed to provide the most possible information in an easy to use and hopefully a user-friendly form. Message Analyzer is compatible with both Anza and Meta pre- and post-processor from Beta CAE systems, but it can also be used as a standalone application, and at the moment we are working on an interface for animated post-processor. The window is divided into three main parts. Left upper pane is a STA file-like structured table used for a main navigation through the entire simulation progress, where each line corresponds to the particular simulation attempt. Right upper pane holds the extracted convergence information sorted into categories according to their type and heuristic analysis report. Lower part is dedicated to heuristic analysis documentation and to the actual message file content, which is converted automatically into an interactive text. Reported entities such as nodes, elements, sets, contact pairs, etc. can be then identified in the underlying pre- or post-processor just by clicking on the particular text. Now let's have a look at a few examples to demonstrate Message Analyzer functionality. Let's take a simple wheel disk model which consists of two parts connected by bolts and corresponding contact interactions. Let's assume there's a pretension force set to 0. This first example suffers from a problem with initial penetrations in the geometry. A common reason of non-convergence of a model with contact pair interactions are initial overclosures. The automatic strain-free initial overclosure resolution is not activated by default for contact type contact pair in Abacus. The best way how to find the initial overclosure is to investigate the message file, and that is unfortunately the moment where we can get into trouble. By checking the STA status file, we can obviously see that our simulation has failed. We should set the preprint contact parameter to yes in order to ensure that the initial contact statuses will be written into message file. We can clearly see that the list of reported nodes with initial overclosure can be extremely long, and to identify the relevant ones with enough big value that could cause the problem is difficult. When we find out such a node, then it's necessary to copy and paste the node number to Anza or Meta and investigate the area in the model. So let's try using Message Analyzer approach. We can start Message Analyzer as a user toolbar in Meta. In the right upper window, we can see the list of heuristic analysis problems and their symptoms. At the bottom part, we can see documentation which is available for heuristic analysis. The other tabs are dedicated to the details information sorted into categories, such as equilibrium convergence, contact convergence, contact status, gap status, and distortion elements. So let's open our model with problems. For loading, we can select ODB result file, and all other files will be located automatically. After loading all necessary files, a navigation table is displayed where each line corresponds to an attempt similar to STA file. Unsuccessful attempts are highlighted automatically, and we can directly see whether an equilibrium or severe discontinuity iteration has been unsuccessful. After selecting particular attempt, the corresponding block of the message file is displayed in the bottom window. We can notice that reported entity patterns, which are normally plain text in the message file, have now become interactive, and we can identify them directly just by clicking on their pattern. Like this, we can easily identify reported problematic node, master set or slave set, or even a contact pair. This entity identification works also for any selected entity in the information tabs, so we can easily identify all problematic regions in the model. By middle mouse click, we can separate the property which the entity belongs to. If we were interested in the particular block of the message file where this entity has been reported, we could customize the mouse behavior and turn on the text highlighting option, and the corresponding block would be highlighted in the message file window. Let's have a look a bit more in detail what Message Analyzer can tell us about the model. We can see that the largest residual force is huge. We can check the actual residual value, its reference value and relative residual value for each entity. So there's obviously something wrong in the degrees of freedom 1 and 3, so X and Z direction. The contact convergence details show us an enormous contact force error, and again we can directly investigate the problematic region by a middle click which separates the contact pair. As the name suggests, the Contact Status Information tab provides the list of reported nodes and their contact status changes during the attempt. Here we can turn on displaying of the complete list of statuses for each node, or just to keep nodes grouped for us. We can use filter and display the overclosed nodes only, and then order them by their magnitude of overclosure. Like this, we can easily investigate the problematic region of any overclosure depth. Okay, so let's have a look what heuristic analysis can tell us. We can see that based on the collected symptoms, heuristic algorithm identified the problem initial overclosure in this particular attempt. When we want to check all identified problems, we can do so by selecting Show All Problems in the context menu. We can see that the initial overclosure problem will probably be the major one and is reported in each attempt. By checking the problem, we can look at the symptoms which have been identified in the simulation, their location and their particular report pattern. And again, also here we can identify any highlighted report entity or all penetrating nodes at once. And what does the documentation tell us about the problem? Initial overclosure. There are an unresolved positive overclosures, penetrations or interactions in the beginning of the contact analysis. The resolving section suggests three options how to fix the problem. Depenetration in preprocessor, move the bodies to zero clearance. Depenetration in solver, or prescribe zero clearance to small sliding contact interaction in solver. Let's go further to keyword hints. Here we can find that the overclosure removing can be done by setting the adjust parameter of the contact pair to yes and prescribing the position tolerance equal to 0. Now we can use the advantage of Anza compatibility and open Message Analyzer directly in Anza. The user interface is similar, except the left panel, which displays the list of contact pairs, sets, properties and materials used in the model. We can again open input file in this case and get the full Message Analyzer functionality. Model entities are listed in the left panel and they are directly available for the attribute modification. As instructed by the heuristic analysis, we can again locate the problematic region, a penetrating node in our case, and its parent contact pair. When I click the highlighted entity pattern, this entity will also be automatically selected in the left entity panel. When selecting a contact pair, its master and slave sets are also selected automatically. By middle click, we can access the entity attributes and perform suggested attribute modification, in our case to set the adjust attribute to yes and position tolerance to 0. So this way we can very easily modify problematic model entities and get our simulation running. Let's have a look at the second example. Let's use the same wheel disk model when there is a pretension force activated now, and let's apply a distributed load. Unfortunately, there are initial gaps in the model in this case, which is another common reason of non-convergence of a model with contact pair interactions, because these gaps cause contact not being identified and activated. Let's see what can Message Analyzer tell us about this particular problem. We can see that there are actually no information provided in the message file, either about equilibrium or contact convergence, except changing contact status report. Heuristic analysis, on the other hand, has identified without any doubts a serious, statically indeterminate problem with its numerical singularity symptom. A problem documentation gives us a general issue description, its symptoms and suggested resolving options. Here we can find that we can either move the bodies to zero clearance in preprocessor, enforce zero clearance to small sliding contact interactions without node movement in the solver, enforce zero clearance by adjusting node positions in the solver. We can change the realization of the loading to displacement prescription instead of loading by force, use contact stabilization, or include an additional stiffness by line entities. And in the keyword hint section, we can find a description how to actually apply these changes to our model. Heuristic analysis has also provided us with an additional hint that the number of nodes with closed status is more than 10% compared to all contact nodes. And the hint description tells us that it's important to avoid initial gaps in the main energy path. The last example is supposed to demonstrate a problem which is a bit more complex. In some cases, a combination of contact and geometrical instability can appear as a result of geometrical nonlinearity. Let's have a look at the rubber seal model and a simulation of pulling a metal sheet in and out of it. In this particular case, a sudden releasing of the elastic energy accumulated in the finger causes the contact instability during the sliding of the nodes out of the surface. A symptom of a geometrical instability is negative eigenvalues pattern. A symptom of a contact instability in tangent direction are repeating changes of contact statuses, sticking to slipping and slipping to sticking, in attempt with convergence issues. Message Analyzer finds the issue automatically, helps us to identify problematic nodes, related contact area, and suggests a solution how we could deal with a particular issue. The documentation states that the geometrical instability might be related to buckling or snap-through phenomenon, and that the global geometrical instability might be resolved by using arc length method, dynamic implicit or explicit solver. Local instability might be resolved by using modal stabilization at step level, contact stabilization or contact damping in the problematic contact area, or displacement type of loading might help. The similar way, we can find a description and hints for resolving of the second problem in our simulation, or any other identified problem in any simulation where we choose the Message Analyzer tool for processing the Abacus message file. If you were interested and you would like to try yourself if Message Analyzer could help you with your Abacus implicit problems, please do not hesitate contacting either me or Mr. Mark Lindhart. Thank you for your attention.